Good morning, everybody, and welcome to this ALU webinar, which is on the topic of handheld laser welding. And the presenter today and our sponsor is Sinan Bilgin. And Sinan is from SS Laser Solutions, a company that he founded about 6 years ago. And Sinan has been selling handheld laser welders for over 3 years now. So I'm very pleased to have somebody who is experienced and knowledgeable about the topic and hopefully can give people the background because these machines are starting to become very popular and very much people are becoming aware of them through LinkedIn and YouTube. And it's good to know the rights and wrongs and the things to do and the things to be careful of. So I will hand over to Sinan in a minute, but I just want to first of all give you a little bit of background to the way the webinar is going to work today. So we have 1 hour set aside for the webinar, and after I hand over to Sinan, he's going to take us through a presentation which will cover all the significant topics that we want to get across today. And then after that, which will be about 30 minutes, Sinan will show a few videos to show examples of how and to illustrate how the product and the process works. And then after that, there'll be the question and answer session where you'll have the chance to participate. You won't be allowed to speak unless you're given the privilege of being allowed to unmute yourself and speak, which we might do at the end. But if you want to type your questions into the Q&A, then we will take those questions at the end, and if they're relevant to everyone, then Sinan will answer them live. Otherwise, if it's a general admin type question, will be answered by text message to you. And then at the end of the webinar, when we run out of time, if people want to stay on, we will be available. If people want to talk to Sinan, we can extend the time period. But the formal business of today will finish at about 12 noon in the UK. And welcome to those people who are outside the UK. I know we have an international audience today, and the attendees can't see each other, but we already have 56 people actually watching the webinar live. So with no further ado, I will hand over to Sinan. Over to you.
Yeah. Can you hear me? Thanks. Hello, everyone. It's nice to meet all of you here on a nice weather with lots of clouds in the UK. So today we'll talk about handheld laser welding with our experience. Of course, you may have experienced different things, or you may have lots of questions about different aspects of laser welding. We are selling these machines for a quite long time in the UK, and also we are starting in the Europe as well. So what do you think, Dave? Should we wait a little bit more or start right away?
I would start right away.
Okay. So as Dave explained, I'm the owner of SS Laser Solutions. We are selling handheld laser welders, sled cleaners for laser cutting machines, consumables, services for lasers, upgrades for laser cutting machines, etc. So generally, we are around laser technologies inside the sheet metal fabrication industry. So let's start with the slides. Okay. So I've divided this webinar into a couple of topics which I find important. But if there is anything I missed, you may, ask the questions at the time of Q&A. I'll be happy to answer them. So first, we'll start with laser power. Then we'll talk about fiber cable and connection type. So I'm not going to read this. You already saw it. So I'll start with the first topic, the laser power. So when it comes to choose a a handheld laser welding machine, generally that's the first thing you come up with. Okay, you ask the suppliers, okay, what's the power of your machine, and generally the answer of this question is related with the price, obviously. So in the market you can see lots of different power ranges, starting from 500 watts even up to 3 kilowatts. So our approach here, because of welding, after looking at welding perspective, if you just go for a lower power machine, which is because the price is low, okay, it's still an investment, but you may find yourself in difficult situations when it comes to weld a little bit thicker material, or if the material composition changes slightly, because power really matters, not just with laser, with any welding technology, really. So for this specific reason, as SS Laser Solutions, we are only focusing into 2 power ranges, which is 1.5 kilowatt and 2 kilowatt. We don't do anything lower than that, and also we don't sell anything higher than that. So why we don't sell anything higher, I will explain when we come to the safety side of it. So the second, generally this question is not coming from the customers, because customer mostly has no clue about what is the connection type or the details about the fiber cable. So as you know, after changing the technology from CO2 to fiber lasers, so let's say realistically around 2008, 2009 in the world, everything changed. So especially this change happened on laser cutting, laser welding. I can say mostly on the laser welding, because previously it was not that much possible to weld with CO2 lasers because of the involvement of a lot of mirrors. But with the help of fiber cable, we can carry the laser light to longer distances flexibly. So fiber laser opened a lot of new venues in the laser industry. So when it comes to the connections, we have 2 options. This is not an option really for the customer, but as an information. So QBH is the mostly used connection type in the laser industry, not just in the welding, but also cutting as well. So QBH is used when the cooling technology is water. So there is a water circulation through the QBH connection. And we can say recently there is also QCS, which is used with air-cooled lasers. So there is no water connection. It is thinner. So I will also explain in the optics section. There is some slight differences between QBH and QCS in terms of collimation lengths. So as I said, as a customer, you should know what is the core diameter of your fiber. I think that's the most important thing you need to know when it comes to fiber cables, because it can be, for example, we have 14 micrometer, 20, 30, and it can go higher, but not on handheld version, maybe automated versions. So when it comes to the laser welding machine, as it is including a laser source, we should be talking about the cooling technology. So water cooling by using a water chiller is there in the market for decades. You know, or let's say 99% of the lasers in the market are with a water chiller with different capacities depending on the power of the laser source. It is proven, so there is no question that if the cooling capacity is going to be enough or what, if you chose the right capacity, that will be okay. But recently, let's say, for the last 4 years, 5 years, we started to see air-cooled laser sources in the market. So this is also integrated to laser welding machines. But when it comes to air cooling, there are two versions, just to simplify, which we name the first of them passive cooling, and the second one is active cooling. So passive cooling has different approaches. Either the simplest way is they just use, 1 or 2 fans and blow air on the heating up surfaces, so create heat transfer on these areas. That can work. There are some machines in the market like that, but the problem is when the factory temperatures or room temperatures increases, let's say over 30 degrees, you will start to feel the power losses. So we don't prefer that route really, because in real life scenario, world temperatures are increasing, and summer temperatures are, even in the UK can go over 35 easily, and especially thinking that this machine is going to run in a factory. So you can't control that. And it's not easy to cool down the whole factory just for the sake of keeping the laser efficiency high. So that's why we use active cooling system. It is basically a fridge. You can think about a fridge. So there's a compressor, there's the refrigerant, there's the heat exchanger. So this system actively transfers the refrigerant to the areas which we need cooling, which is laser source and the torch. So that keeps the cooling efficiency high. So this is the explanation about the cooling difference, but also water cooling has a slight disadvantage because of using water. So the water has to circulate to the torch as well. So you will have one inlet and outlet. So that will bring a little bit more weight on the torch because of the water involvement. Whereas in air cooling, it's just a refrigerant, you're not going to feel the weight of it. So every laser technology has a head. So in laser welding, we have a welding torch, and there are optics involved in it. And also, normally we have the controller. So when we think about the welding torch, luckily customers are having ideas about, which or deciding which torch to choose when buying a laser welding machine, because you may see some machines in the market with bulky torches made of aluminum, and there is no protection cover around them. So they will still work. But the problem is when there are some intricate parts which you are going to weld, like boxes or whatever, you may see that you're not able to position the torch inside the product. So that is not going to allow you to weld that specific part. So you may need to go back to MIG and TIG, which really hurts because you already made a significant amount of investments for laser welding. So for that specific reason, our first focus is to have the smallest size possible, low weight on the torch and also on the connections. Optics should be replaceable. So all our machines which we sell, we are able to fully disassemble the torches, replace all the optics, put them back again, and then it will be like brand new. So when customers ask us, is there any lifetime of the torch, or what is the cost of a torch if they need? Normally, you will not need to buy a torch from brand new. There are, of course, some options, which if you burn the torch or if you run a forklift over it, okay, in that case, you may need to replace it. But it's all the optics, you know, we have the protection lens, focusing lens, reflective mirror, and the collimation lens. So when these optics are changed in time and the internally head is clean from contamination, your machine will work fine on the torch side. So when it comes to the consumables of the torch, as I said, but let's add the nozzle as well. Nozzle is the first contact point of the torch to the material. Generally, they have long lifetime. And apart from that, we have wire feeding tip. It has a long lifetime. So the main consumable on the handheld laser welder is the protective lens, which is the first barrier of the torch, which prevents the contamination to get inside. So you may need to change it time to time. There is no significant lifetime for it. It depends what you weld, how you weld, what is your gas pressure, flow rate. So there are a little bit more variables in that, but they are not too expensive, I should say that. So the second part, the controller. So we always focus in user-friendly controllers. So we have two different models in our product range, but both of them has the same mentality, which the machine comes with a standard set of parameters for different materials, different thicknesses, if it is with wire or without wire. So the operator just need to choose, for example, mild steel 3mm with wire, it's done. So all standard parameters are coming automatically, including the wire feeding speed. So the operator will give it a go. 90% of the time that will be sufficient, so he can weld, she can weld the product. But if you want to weld faster, slower, wider, narrower, then you just need to change that specific parameter and keep on welding. So you don't need to know anything else apart from the material type and thickness. There are possibilities to weld in continuous welding mode or spot welding, pulse welding mode. So this topic is a little bit detailed, which we talk a lot at the time of our trainings. So I'm not going to extend that specific topic too much, but if you will have any questions about it, you can ask at the end. The other difference when you compare to MIG and TIG, you don't need to manually wobble the laser welding torch as you do on MIG and TIG. So the machine has a reflective mirror, which is attached to a very fast moving motor inside. So as per the wobble width or scanning width or welding width, there are different terms for it. This mirror is going to move automatically as per the set width. So you just need to pull it towards yourself. So this is a little bit related to the training, but I just wanted to give a little bit hint what we are talking with the operators at the time of training. So for example, top left side, you can see different welding types. It can be butt welding, lap welding, fillet welding. This is not a training. It is obvious. Every welding involves these things. But what we say is every different type of welding needs different approach. So butt welding is not same with fillet welding in terms of parameters or your angles, your tilt. So we will be talking a lot at the time of the training. So the good positioning of the material and also the torches, preferably there shouldn't be any gap between the materials, because laser welding is significantly different than MIG and TIG in that aspect, because we don't literally use electricity to create the spark. We use only laser light. So for that reason, laser light has a very small spot size. So if you will have a little bit bigger gap than the spot size of the laser, and if you don't use the right thickness of the wire, the laser will just pass through from that hole. So having a bigger gap is always a problem. If you cannot eliminate it, you should be changing your wire thickness. And also, if you target the laser beam wrongly, then you will see that either you are missing the line, or the penetration is not symmetrical or is not strong. So depending on the wobble width and the peak power of the laser you are using, you will get different results. So I'm not going to talk about this right side of the slide, but basically you will get these kind of shapes, which we try with the operators at the time of the training. So wire feeding is generally the most common question we receive from the customers, because some of the customers, they have the impression that when they buy a laser welding machine, they don't need the wire, they can just fuse it. It is yes and no at the same time. So let's talk about just fusing without wire. So as I said in the previous slide, you should not leave any gap between the materials if you want to fuse them only. Okay, so the gap shouldn't be there. The second thing is the thickness. So you should be, okay, the thumb rule, I can tell, around 2 millimeter, 3 millimeter is going to be your realistic maximum to have a good penetration without using wire. Because when you melt the material, as you're not using any filling medium material, then the weld is going to collapse. So you can weld it, but on the other hand, it's going to get thinner compared to the other side of the plate. So with thinner materials, you know, around 1 mil, 2 mil, that will be fine. So this is the second thing. But the third thing, I think this is the most important thing. Normally, laser welding machines need less skill. But when you don't use wire, you need a little bit more skill, because there is no speed guide for you this time, because there is no automatically fed wire. So you should be pulling the torch with how can I say, with the same speed at all times, which is in real life, it is impossible. And if you have a couple of different operators who's using the same machine and you are making a batch of products, they are not going to look identical. So this is problematic in my opinion. That's why at the time of training, we tell the customers, if it is not visual, if there is any load involved, if it is constructional, whatever, always use wire. If you want to use thinner wire, okay, use thinner wire, but use wire, because as the wire feeding machine automatically feeding the wire with a set speed, that will be your guide. So operator A, B, C, whoever welds the same box, same part, same product, they will look identical. So if I were in your shoes, I would be using the wire feeding at all times. So when it comes to the wire feeding types, we have single reel wire feeders and also double reel wire feeders. So single reel wire feeders are standard, double reels are optional. So double reel can hold 2 reels of wire at the same time. They can be same or also different wires. So you can choose to feed wire A, wire B, or A and B together to create a thicker buildup. So it is your option. So you need to be, when it comes to wire, generally the question is it a special wire for laser welding? No, MIG wires, they're they can be used on laser welding as well. The most important thing is you should be choosing the appropriate wire material, because if it is not chemically creating a nice combination with your, sheet metal profiles, whatever, then you may see porosity, even fine cracks. So always use good quality, same quality wire as much as possible, then it will be problem free. So you can also, that's the only way you can fill the gaps, by the way. Without wire, you can't do that. Let's be realistic about it. And also you need to be using suitable wire feeding hose. Why this is important, especially with aluminium, because aluminium is a softer material. So we have special wire feeding hose with a graphite coating inside, which reduces the friction. So you can easily feed the aluminium wire. You should be choosing the suitable nozzle and the wire feeding tip as per your wire thickness. And as I said, choose your wire thickness wisely, depending on your material thickness as well as the gap. So when it comes to safety side of the laser welding machines, so the left-hand side, the welding torch contact signal, different companies name them differently, but it's the same job they do. So it's a crocodile clamp, which is very similar to MIG and TIG earth connection, but this connection we don't use for earth. It is a connection signal. So this clamp has to be positioned on the welding table at all times. That's the first rule of the safety. At the end of the training, we get the confirmations from the operators that they have to keep it over there. So the only way to turn the laser on, that laser torch should be in physical contact with the welding table. So whenever you remove the torch away from the table or away from the product which is in contact with the table, even if you are pressing the trigger, you're not able to get the laser light. So generally, all machines, they have this signal already built in. But the second side, the right side of it, the door interlock signal, which is very important. Some companies just name it with a dual signal, which is correct in terms of explanation. So we have a second signal which the machine can get. So that is used for the door interlock. So why do we need it? Because the operator is going to have their PPE on, helmets, goggles, clothing, etc. But if there are any other people in that environment in the factory, so those people, they don't have the PPE. So the machine should be running in an enclosure. There are different options that can be discussed later. So that enclosure's door should be interlocked to the machine. So all of our machines are coming standard with the door interlock signal, and not just the signal, it is also coming along with the door switch. So the customer doesn't need to buy the door switch, get the signal interlocked to the door. It is already built in. You may just need to extend the cable if you have a much bigger room than the cable we supplied. That's it. So when the door is open, the machine should be stopping automatically. So I just want to show you a quick video about how it operates. Okay, so I think you don't hear the sound from the video. Let me quickly explain it. So when you open the door, so what we are doing, just removing the switch. So the machine is going to the alarm mode. Okay, now we are opening the door and the machine is going into the alarm mode. So if you try to reset the alarm without closing the door, you will see that it's not possible. So you have to close the door, then reset the operation. Then the machine is going to allow you to work with it. Okay. Now the PPE and the laser enclosure side. So this topic is, I think, the common concern of everyone thinking to buy a handheld laser welding machine, which we know from the past, as per our experiences, there were solutions for that. Previously we were supplying laser protective goggles and a helmet on top of it. So that is a full face covering and also at the same time laser protective solution. But the main downside of that solution was the comfort for the operator, because wearing a goggle and a helmet on top of it, it's not comfortable for long hours. And consider there are some people who is also using prescribed glasses. So we were already discussing with the PPE manufacturers in the world regarding this requirement. But because this equipment has to be certified, it took time for them. There are a couple of suppliers in the market which, for this specific helmet, we work with Laser Vision. So right now, that is a standard equipment going with all of our machines to the customer. So they receive the helmet, then it's a full face protection, full laser protection. It also has plasma protection. So it is lightweight. When you don't use it, when you're not welding, just turn the visor up. You can freely keep it, on your head for hours and hours. It's not going to create, any discomfort. So it's basically this one, the helmet. You have the adjustment knob at the back, like any welding helmet. Put it on, adjust it to your head, and that's it. When you don't use it, just leave it this way and close the visor when you're good to weld. It is very comfortable. You don't have any openings right now. All facing angles are fully closed. And consider that you're wearing your gloves, your welding clothing, then the operator is fully protective. They're also working with the air-fed version of this. I think it will be soon ready in the market, because some companies, they have a preference to have air-fed solutions. So gloves and clothing is a common protection for welding, not just specifically for laser welding. Always wear your gloves, always wear your welding clothing. And I can say maybe a funny trick: never put your hand in front of the laser torch, okay? Because as light involved, any reflected light can easily come to your hand. So it might be painful. It will heal, but I wouldn't advise that. So when it comes to protective enclosures, there are different materials which you can use, or you can ask your PPE manufacturer to use. But basically, you need a laser protective enclosure. So the standard welding curtains, which is available in every fabrication shop, is not laser protective. So if you try to hold the gun, even from a longer distance with a lower power, you will see that I'm not going to command how many seconds, but in a short period of time, you can damage it. So I would advise to go for a bespoke. Right now, it's not that much bespoke, but 3x3, 3x2, 3x4, 4x4. You know, these are kind of standard dimensions for enclosures nowadays. But if you would like to have anything bigger than that, we can also give you an offer for that specific requirement. If you don't have any, you know, these rooms generally they have an optional roof. So why optional? Because if you don't have anything on top, you may choose not to cover it with the roof. But if you have any mezzanine, any offices or whatever, then it's better to go with the roof option. You can have viewing windows. It's up to you, or you can have a CCTV camera fitted in, which I prefer mostly, because when there is CCTV, you can see that view, not just outside of that room, but you can also have one screen in your office. So it is much more convenient. And these enclosures are going to be interlocked with the machine. So whenever somebody opens the door, the machine is going to stop automatically. And when the laser is working inside, the laser on light is going to be on. So everybody will know that, okay, there is laser operation going on, which I didn't put in this slide, but there is also fume extraction topic, not specifically for laser welding, but fume extraction is a must. Okay, so either you should have a mobile extraction unit or fixed extraction system in the factory, but that welding fumes have to be removed from the environment. So don't think that laser has, or laser is less dirty or whatever. We are still melting the metal, so that creates fumes. So it's not different than any welding system. So welding gas, another topic which we time to time have, not time to time, every time have questions from the customers that either if they need a welding gas or what kind of welding gas they need. So in reality, the most common gases are argon and nitrogen. There are also some areas which helium can be used, but it's not that common. Argon, considering the price of it, as it is cheaper than nitrogen, it will be sufficient for most of the jobs. But there are some scenarios which you may see some pinholes, some small porosity with argon, which can be eliminated by using nitrogen. So either you can have both, if that's up to you, but most of the time argon is sufficient. Some companies, they have laser cutting machines already in their factories, and they have a nitrogen generation system. So the same nitrogen you can use for laser welding as well. Or if you are really using gas too much, you can purchase an individual nitrogen generator for your laser welding system. We can help you with that if you would like to go for that route. And why gas is needed is, first, it needs to shield the weld. That is common with every weld. But additionally, this gas is also protecting the optics from the contamination. So this is the last topic which I would like to cover with you. There is one thumb rule, which is a good advantage with the laser welding, is it is much easier to learn compared to MIG and TIG. So there might be a couple of different reasons for a business owner, for a production manager, to think about going for a laser welding machine. But this is the most important thing, that if you have juniors, if you have no one but you as a business owner, so you're in the production, that means your welding process is not going to stop because you can weld with the machine. But as SS Laser Solutions, this is maybe having 50% importance for our sales. You know, we should give appropriate training to the operators who are going to use the machine. So we see in the market, you know, that companies who are giving 1 hour training, 2 hour training, maybe if you're lucky, half a day training. This is not sufficient. You know, you can turn the machine on and off. That's it. There are a lot to be discussed about the parameters, about different materials, about wires, about safety side of it, how to keep the angle, how to change the optics, because if you don't do it properly, you will damage the machine. There's a big potential. So for that specific reason, we go for a 2-day free of cost training at the customer's place. Okay, so this is not going to change with our machines. So we give the first day of training at the time of delivery. It's a full day. We do the delivery, by the way. So all of our machines are coming with free delivery. So we do the training. We have a digital training form. We go over every topic which we discuss with the operator. So we do this individually with every operator. Then there are some confirmations which the operator has to approve and personally sign, because it's not just protecting us, but it's also protecting the owner of the machine, that the company, that we have to make sure the machine is going to be used properly. They have a lot, you know, laser welders, they have a lot of advantages, but they are powerful machines. They have to be handled carefully. So presentation-wise, we covered all the topics. So I will briefly show you a couple of videos, not too much, because
when you share the video, select share sound, and then it should hit if you want.
okay. Let me try that. I'm going to show you some realistic welds which we made with the customer or without the customer. So where can I share the sound, David?
When you share it to the top video, transitions.
Advanced sharing options. Here. This. Okay. So I didn't chop this video. That's a realistic part from one of our customers. So we are not focusing only, you know, visually good-looking parts, which is, you know, easily done with laser welding. But for example, this specific product is going to be used under pressure, okay? And it's going to stay like that for around 2 days. So there should be no leaks with it. We made a couple of samples for this. So this is, I think, the second version of it. So we made 4 samples without seeing the actual product. And last week, all of them were tested and all of them passed the test. So let me show you another one. This is a video from the training, which we really want to make sure. Let me bring it this way.
Sort that angle like that.
Yeah, that's good. So we need to see that every operator is having a good feeling of the wire speed. So we repeat this process. Sometimes it looks boring, but it will make sure that these people are going to use the machine nicely. And on day 1, you will be able to start manufacturing. So as I told you, like every laser technology, laser welding involves optics as well. So this is a collimation lens which has been removed from a machine. As you see, because of a back reflection, there was a damage on it. So without replacing these optics, you can't keep on running, and you should not keep on running on the other hand, because if you break this optic, you can damage whatever behind it, which is generally the fiber cable. So it will end up with a damage. Okay, this is the one. Let me show that to you. Which will end up with a damage like this. So this fiber cable has been damaged by a back reflection because the operator was not obeying the rules of how to hold the torch with an angle. Sometimes, even if you know the rule, but some products are not going to allow you to keep your angle. So in that specific cases, we tell the operator, if you see that you are not able to keep your angle safe, then tell your boss, tell your production manager that this product is not suitable for laser welding. Okay, so this is important because then you can damage the laser source like this, which you may end up with a lot of repair cost. So we give services to our machines to any laser welding machine in the market. So when it comes to optics, you should not leave any gaps. If it is a protection lens, if it is a focusing lens, that has to be clean. For example, for this specific torch, the protection lens was nearly shattering, and after we see that the focusing lens was dirty. So now this is the last photo. So when you wear this protective clothing, gloves, and the helmet, you will look like this. It is comfortable, I can say that, thanks to the new helmet from Laser Vision. So from presentation perspective, we are done. I think, Dave, we can
move for the Q&A session.
Thank you. Thank you very much, Sinan. Yes, we have a few questions getting lined up in the Q&A.
Okay.
I think the best thing to do would probably be to take the welding questions first, the process questions, and then there's a few questions about safety, which we can take as well. Phil Carr has asked a few questions. One of them is this handheld laser welding more like MIG or TIG? Which is a good question.
Okay.
So, let me explain it. That there's a huge difference.
Of course.
MIG and TIG is there for decades. They are proven in the right
areas. If you're welding thicker materials, if you're repairing stuff, they're still good. I should say, when you buy a laser welding machine, you're not going to get rid of your MIG or TIG. So I'm telling this for two reasons. One, for the boss, don't think of getting rid of those machines. And one, for the operators, don't think that you're going to lose your job. Because laser welding is a little bit scary topic for the operators, that as it is easier to use compared to MIG and TIG, some of them, they may think that, okay, it may make them to lose their job, which is not like that, because as MIG and TIG is still needed for thicker materials, for repair stuff. And it's also better to grasp the technology. So laser welding has, some standard advantages. It is generally faster than MIG and TIG, 3 times, 4 times, sometimes more. It is cleaner, and it's easier to use. So the other question, Should I pick from the top? Right.
So there's a question next about wire diameter. Phil Carr asks, we weld a lot of aluminium with small wires and have wire diameters down to 0.2 millimeters. What are the practical sizes of wires, particularly in aluminium?
Okay, my personal experience.
With aluminium wires are, there are a couple of things you should check before using aluminium wire. The first thing, as I said in the presentation, the liner you use, or wire feeding hose, you cannot use the same feeding hose, which is for mild steel and stainless, for aluminium, because it has more friction inside, so you will not be able to feed it. So use properly coated hoses you can buy from us, or if you already have it, use that one. So that will reduce the friction. The second thing, even if you reduce the friction in real life scenarios, anything lower 1.2 millimeter aluminium wire is not going to be that easy to handle. You can weld it. It's all about the experience. But as this machine, it's known to be easier to use, I would say don't go anything below 1.2 and use 1.6 if you would like to create a thicker buildup. We always have good results with 1.2 and 1.6. We have customers who are welding 100% aluminium. They are happy with it. So the other question.
So next question is about gas. Two questions. One is, can you use ArgoShield gas? And the other is asking about the cost of nitrogen versus argon.
Cost, starting from the last, cost of nitrogen versus argon, it can change depending on your supplier, depending where you live, depending how much you buy from your supplier. But generally, nitrogen is expensive than argon. So price-wise, I can't comment. But we use, for example, in our showroom, we use pure argon. The supplier is your choice, but we use VOC, but you can also use nitrogen. But the gas has to be pure because we need an inert gas. Inert means it shouldn't be getting into a chemical reaction with the material. So that's why it is a shield gas. So if it is getting into a chemical reaction, that will negatively affect your weld quality. So the other question?
Was about ArgoShield.
As I said, we use pure argon. So it has to be pure argon. When you say ArgoShield, that can be a brand or naming from a different brand. So personally, I don't know it, but it has to be pure argon. For example, BOC says it's pure argon, it's on the bottle. So there is no other gas but argon inside that bottle. So we are sure that there are not going to be any chemical reaction.
Great, thank you, Sinan. So there's a question now about, are there any adds-on to your device to help an operator to control the welding surface angle, the laser surface angle? Because the operator cannot control the welding angle during spot welding, and this affects the welding quality very much.
Angle controlling, we have some projects which is going to be attached to the nozzle, but it's not there in the market yet. But it's not that problematic to keep your angle because that angle is not very specific. What we say around 45 degree, okay, but this can be minimum 30 degree, maximum 70. That's the safe zone. Why we say it's safe? Because when this is your material and when this is your torch, when you have an angle, most of the power is going to be absorbed by the material, and there might be some scattered light going with different angles, but generally with this direction. But if you keep your angle 90 degree with a right angle to the material, any back reflection, especially until you create the first melt pool or weld pool, then it will be quickly reflected back to the torch, because the biggest amount of reflection is before you create the weld pool. Okay, so it happens within a second time. less than a second time, really. So that's why customers have back reflection problems. They say it happened all of a sudden, because this is light, it happens all of a sudden. So always keep your angle. And when it comes to spot welding, we have some parameters which we can fix the spot welding time. So by choosing that parameter set, you can make sure that all spot welds are in the same quality. So there is a lot to discuss about that aspect, but unfortunately, this webinar is not going to be the right place for it.
Okay, thank you, Sinan. That's
You're
very
welcome.
helpful. The next question comes from Phil Carr. With a machine laser welder, we have an air knife to keep the lens and the glass protection clean. How do you keep the laser source free of dirt?
With the laser welding, as I said, on the gas section, we use the gas also to protect the optics. Not just we, all laser welding machines use the same mentality, because the gas is going to be purged from the torch towards the material. Okay, so that will prevent any contamination to get inside. I think we can't say any, but less. Okay, because if someone on our machines, it's not possible, but there are some machines in the market which is not fitted with a flow sensor or pressure sensor, which the operator can reduce the gas flow. And that is dangerous because the contamination can be quick. So our machines are standardly fitted with pressure sensors. So you cannot reduce the gas flow below the safe zone. Otherwise, the machines will go on alarm mode without turning it up. You can't run the machine. So we need to make sure that the gas flow is always good, so the contamination is out. But whatever you do, there will be some contamination, either from external sources or from sparks, or when you don't use the machine, if you are leaving the torch on the welding table and grinding very close to the laser welding operation, then that's going to reduce the lifetime of the optics. It's not different compared to laser cutting or laser welding. It is same, but it is a mobile machine. It's a very flexible machine, so it is more open to contamination compared to laser cutting.
Okay, and in that line, do systems have something that kind of warn you when maybe your lens is damaged, or how do you know when you need to do a replacement of that?
There are very, how can I say, easy signals, which we discuss at the time of training with the operators. First, the very easy one, when you set your parameters, let's say your power is 700 watts, 800 watts, and you know how it welds. So within a second time, when you start, first you will get a good amount of power and it will immediately reduce. So this will happen within a second. So that's the best sign to understand there is an optical damage. It can be protection lens. So you change the protection lens, try it. Okay, if you see that the power came back to normal, go on welding. But if you see that still there is a power loss, then you should suspect the focusing lens. Change the focusing lens, and if you still have that problem, then we should be checking the collimation lens or reflective mirror, because that's the best sign to understand that there is an optical damage. And the worst case scenario, you might have damaged the fiber cable as well. This is very rare, but these are the scenarios.
Excellent, great. I think we have time for one more question, and then we have a few more in line, but we'll cover the safety one first, because I think safety will be the last one. People are asking about whether full face helmets are always required and not goggles, and are some of these helmets CE or CA certified?
Yeah, so helmets or full face coverage is always required, because as like every light source, light sources, they create radiation. Okay, so we should be protecting our skin, our eyes from these reflected lights and UV radiation. So that's the answer for that question. You should be using a helmet like this, or if you don't have it, if you don't want to buy it, you should be using laser protective goggle, which we also sell. But when you use the goggle only, you should be using an additional helmet over that goggle. So it's up to you. It's not that comfortable, but it is a solution. And when it comes to certification, yes, both the goggles we sell and also the helmets we sell, they are certified, because helmets are from Laser Vision. If the customers or whoever interested go to our shop at sslasersolutions.co.uk, you can see the helmet, you can see the documentation, you can download it, the details are there, and same for the goggles as well. We don't sell any PPE without the certificate.
Excellent. Thank you very much. I'm afraid we're out of time now for the rest of the questions. We will try to get to the questions offline, but in the meantime, I'll hand back over to Dave, who can help to wrap up. And let's say thank you again to Sinan for a really interesting presentation about handheld laser welding.
You're welcome.
Thank you very much, Sinan. Thank you, Simon, for
Thank you.
dealing with the questions. As Simon mentioned, we've had I think 31 questions asked and 14 answered. So we don't have time to answer every question. Some of them are comments, not questions as well. And some of them is a bit of dialogue going on between different delegates, so answering each other's questions. So we will have a record of all the questions at the end of the webinar, and we will be able to answer those separately to the people who answered, because we have your email addresses as well. So I think that it's been a very useful webinar. Thank you very much, Sinan, for your time and putting it all together. And I think that I would like to signal a couple of things coming up. We are planning to do a similar webinar on laser cleaning. We haven't yet confirmed who the sponsor for that one is going to be, handheld laser cleaning. And then we do have coming up later on in the year from ProLight on the safety side. They'll be looking at the safety of handheld laser systems. So we don't have a date set for that, but watch out for that coming up, and we will be sharing that information with you. So I know that safety is a critical topic on all handheld laser systems, whether it's welding or cleaning, and they each have different requirements. So we will be covering that in a separate webinar. And if you like this webinar, then look out for more webinars like this coming up. This is kind of a guinea pig, first one, but we expect to be running quite a few of these in the future.
Can I answer one question here?
Sure.
Shortly.
Yeah.
There is a gentleman called Rick Jackson. He was asking what is the issue with 3 kilowatt, for example, because I told in one of the slides that we don't go over 2 kilowatt. It's not because it is not possible to build 3 kilowatt or anything higher power than that, but because there are safety concerns. Okay, when we are talking about, you have to wear helmets and everything, that's basically because of back reflections, scattered light, whatever. So if you increase the power from 2 kilowatt to 3 kilowatt, that means it's a 50% power increase. That also means there is literally a near to 50% increase on the scattered light, on the reflected light. So that means you need more protection. So what our approach as SS Laser Solutions, if your process needs anything more than 2 kilowatt to weld anything thicker, don't go with a handheld version, go with an automated welding solution, which we have. Then we can eliminate the operator from the process. So that's going to be a class 1 laser rather than class 4 laser. So that's the answer. Both with 1.5 and 2 kilowatt, we can weld up to 6 millimeter. Because normally people are expecting with 1.5, we can weld thinner material because of the power difference. No, this is mild steel and stainless steel. I can say 6 millimeter. But with 1.5 kilowatt, we use a different fiber cable with a different approach. So we can keep the thickness the same. And 1.5 kilowatt is air cooled. 2 kilowatt is water cooled.
Okay.
Okay. Thank you very much, Sinan.
Yeah,
We're 5 minutes
All
over
participants.
time. So what I'm going to do now is I'm going to close down the webinar, and the recording of this will be available shortly, and that will be in the public domain. So it will be on Vimeo and YouTube, and we'll be sending out links to everyone afterwards. We'll also be sending you a feedback survey, so you can give us your thoughts about how informative and useful this webinar was. But thank you very much for attending, and I'm going to say goodbye and sound off now.
Thank you very much for your participation.